So in this video today, this is our lecture 3 of functions, right? So in this video we'll be discussing about the graphs of some popular functions that will be needed, right? So let us now do it. So first, my favorite graph is a logarithmic graph. So how we can do it? We have to just plot. It has two conditions and two cases. Logs graph can be like this. If log 1 is 0, everybody knows. This is when a is more than 0. What is a? A is this thing, log का base को हम a बोलते हैं a. Else log graph can also be like this, when your a lies between uh, 1 and 0. Sorry, I made a fatal mistake. It is when your a is more than 1. Alright, when your a is more than 1. ठीक है. This is the log graph of make sure to make this change. Okay, this is the graph of log. Now let us show you the log of e to the power x. So it is the inverse of log. Okay, like I let me just show you it in a very good way. Like it is like the mirror image of log, right? So this is the graph of log when your a is more than 1. Can you draw the mirror image of it? Suppose this line from the origin is your mirror. It is your mirror. So what will be the graph looking? It will be looking somewhat like this. And this is your graph of ax when a is more than 1. Alright guys. Now suppose you have to draw the graph of ax when a lies between 0 to 1. Again we'll be using the graph of log to draw it, right? You know when the graph of log would be what? The graph of log is like this for this region. So again you have to form the mirror, and then you have to, okay, how will you do it? Of how will this parts, only this parts image, how it will be this part? It will be somewhat like this. Like it is coming from here, so it will be going from here. And how will this parts image will be? It will be going from here, right? And that's it. This is the graph of ax. Only this part I am highlighting. Only this part is the graph of ax, right? When a is more than 0. So what's a good way to visualize it? So that is the two graphs that we are needing right now. Then I am telling you about some properties of a function of GIF. We'll be doing GIF, okay, and GIF function will be telling you about the greatest integer. I think the paradox changed, but all right, okay. And let us also discuss about some properties and what we have right now. GIF, okay. So GIF is what? If you have a thing called 4 point, let me just black 4.56, GIF will always give you the greatest integer function, so it will give you 4. Okay, people understand GIF very easily, but what if we have a different function like negative 4.56? Always remember that GIF over here doesn't give you 4, but it gives you, think and answer. It will give you -5, right? So why is it? So let us understand it via the graph. Okay, I'm opening here Desmos. Let us understand the GIF properly with the help of a graph. Okay, it will be beneficial for us. Functions, so you have to go to functions, then uh, have a thing called GIF, right? Actually, I'm taking a break, so I'm studying and I'm doing making this video. Else, I don't make this video often. Yeah, you guys know that. So, where's the box function, man? No box function here. Uh, what the hell? Okay, all right. Oh yeah, seal. Okay, remember seal is also seal is the box function. It's the other name of it. Okay, so this is how the graph will look. See, it is stepping up. It is stepping up. And see, it is stepping up. So this is the graph of GIF. So as I told you, if I put here 4.53, what will the graph give? You say nothing has been given, so see, it will give you 5. This is the graph of seal, okay? Because GIF doesn't give you 5, GIF gives you 4. So if you search at R seal and GIF same, the answer will be no, they are not same. But I want to show you GIF, right? How to access GIF in this mouse. Yeah, just search it. I don't know. Um, this mouse GIF, GIF function. GIF function, how we can show. Acha, sorry, it's flow. Sorry for the misinformation base, it's flow. Ah, actually, I am not very much familiar with this mouse. I always use my copy, but in this here I cannot draw it globally, so basically, okay. If you draw the graph of flow, yeah, that's it. That is the function of GIF. Alright. Now here if you put 4.56, you see the answer it has given is 4. If you plug in here minus 5.66, you see it has given you 6. Why is that, man? Why is that? Because I will show you from the graph. Alright. This is the graph of GIF. Alright. So you can see here GIF graph is very much constant. Okay. If you plug in some values, if you give x a value, it has some integers. Okay, you can see it has always has some integers. I mean, GIF is very integer prone. Means you will see it has no range, no output line in the part of other values. It has only the values available in uh, the integer line. So if you put here y equal to gfx, you can understand it quite clearly. If I put here x equal to 4.6, you will observe that a line only from the 4 has been drawn. Why is that? Because GIF doesn't allow you to do this. So I hope you guys can understand GIF. GIF graph is a bit of complicated to understand because it always gives you the integer value. You may remember that. And while for negative values, it will give one negative less. Alright, so that is the ninja technique to remember GIF. So now let us discover some more graphs and let me give you some ideas of more graphs. So, for example, sin x. If I have the graph sin x with us, see, sin x is a graph whose period is 2 pi. Okay, it is going. You can just see it is the maximum of sin x 1 and it is the minimum of sin x, that is minus 1, and this graph will go for infinity. What if I give you a question that uh, half is equal to sin x, how many solution will it have? The answer is infinity, but we can prove it. How? If a line here, sorry, if this is my function, say y equal to sin x, and y equal to 1 by 2, you will see this line from 1 by 2 is intersecting the sin x, so it is making here many solutions, infinite solutions. So this is the graph of sin x. Now similarly we can analyze the graph of cos x2. This is the graph of cos x. uh, it is same as sine, but bit shifted, pi by 2 shifted here. Its period is also 2 pi, and its range and domain is also known to us. So now let's do tan x2. Tan x, you can see is like this. At it is 0 at 0. Okay, and see here it is becoming infinity when it is becoming undefined at pi by 2. All right. So it's what is its period? Its period is nothing but pi. You may see. All right. Now let's clear this because the screen is full of tans, and you don't want so much tans on the screen. Okay, so now let us discover some more graphs. Cortex is similar to tan, so I'm not wasting my time showing you cortex. Okay, now let us have a look at the graph of. It's an interactive session. I'm not a teacher anyone. Okay, I just want to interact. Mm, let us do the graph of what we are still. These are not some important graphs. I guess important. Okay, I let me visualize with the EXP graph. I guess I didn't. Uh, it's this is not the graph. Okay, I feel I'm very bad at this. Okay, I'm showing you manually, okay, by typing because I don't know how to find all this stuff. A power x. Yeah. Up the curve. You have to plug in some values away, right? Because the graph will take turns. See, I'm making you visualize much better. When a graph of ax is more than one. Why? Why? Oh, acha, acha, sorry. I drawing in a bad way. Oh, sorry for the break, guys. Let me show you the graph of a reports. So let us draw the graph of two coordinates. A famous graph. It will be like this exponential graph. What if I change 2 to half? You will be seeing the opposite thing happening as I taught you in the theory classes in my board. See the exactly same is happening. You will be telling that it is touching, but it is not touching. It is going on. It is going on. Imagine it will meet at infinity. Okay. See how much different, how much space is there. They're touching. They're not touching. When they let go, it is decreasing. It will should be touch now. It will should be touch now, but it will not touch. It will touch at infinity. No matter how much far you go. Let me show you. So you will right here. It has surely met, right? But no, no, no. You so when you will be saying, oh, it has touched. Nah, bro. Let me zoom in. Have to zoom in more here. I'm tired. So see, the gap has been created. So this is the graph. So that's it for our session today. We discuss about graphs. Thank you guys for watching.